Thank you, Ernst. Nice to see you. Of course, enjoying a real beer, not just a virtual beer together would be much, much better. And congratulations on this center, and thank you for inviting me to this wonderful event. Ian and Andre for co-organizing it. And so, as I had hoped, thought that Ian would already offer many explanations in terms of the potential of AI, what AI is not, how we can use it. And I want to, I believe, build on that by focusing on how AI helps construction project teams add value. Because at the end of the day, right, that's what we need to do. We need to add value to society, to our clients, and to ourselves, I would say. So for me, AI is really a scientific tool because it allows me to bring the business and the scientific perspectives together. As you heard, I do a lot of my research in the context of SciFi, the Center for Integrated Facility Engineering, where we have the privilege of working with many leading companies around the world. And for them, right, they need to continue adding more value to their customers. And a big part of that is to become more efficient. And Alan Perley pointed this out many, many years ago, before automation was really that big, certainly of knowledge work. Automated execution of processes changes everything. So if we can automate something, and I understand Ian's caveats, of course, then we have something that is valuable, of course, assuming it works well. And this is where the scientific perspective connects with the business perspective for me. Well articulated by Donald Knuth in 1974, a Stanford computer scientist, who says, science is knowledge which we understand so well that we can teach it to a computer. And obviously, as a scientist, academic, I need to produce scientific knowledge. So if we cannot fully understand something, it is an art to deal with it. And Ian pointed out many, many aspects of where our work in civil and environmental engineering, architecture, construction is still an art. Since the notion of an algorithm or computer program provides us with an extremely useful test for the depth of our knowledge about any given subject, the process of going from an art to a science means that we learn how to automate something. So trying to bring AI tools to understand our work allows me, us as a community to understand the frontiers of our knowledge, of our scientific knowledge. And it allows us to provide better tools that allow us to actually learn more and advance the frontier. And of course, it's not a question of either or. It is really about the power of and. Having said that, I will take apart a bit what, in my experience, computers are good at and humans are good at. But the point is really to be clear on it so that we can leverage this power of and, the humans and the AI tools together. So how can AI add value to AEC projects, architectural engineering construction projects? We can add value, of course, by increasing the value addition for our customers. That really means that the controllable factor, the things we're changing, is the product or service that we are offering to our customers. But we can also add more value by streamlining non-value adding but essential activities, basically thinking about leaning our processes. So here the controllable factor is how we organize ourselves, the processes we carry out. So when I think about adding more value, I look at the opportunities from improving the product and service, but also from improving the process and organization that deliver this product and service. If we put this into a 2x2 matrix, that's what you get when you work with businesses. Put product, organization, process there, and maybe slightly provocatively, but just also so it's simple and easy to remember and also fits in a reasonable size font, what humans can do and what humans cannot do. Of course, you might find a human that can do it, but what I mean by humans cannot do is you cannot easily do it every day on your projects. So if you put those together, of course, we already have products that humans can do that already exists. So the improvement opportunities for me are really in the other three boxes. We can execute our work more consistently, more efficiently through the help of AI. That's, I think, a huge potential here. And we can think of new and improved processes that are really quite challenging or almost impossible for humans to do. And we can also imagine new products or improved products. So I'll give very quick examples of these three boxes, starting really in the lower left corner, because that's what brought me over to the US, to the West Coast, where in the mid-late 80s, AI was going to take over the world any day. So I wanted to be there and learn about that. This is a project I worked on as a young engineer, a project in Rhode Island, actually for a Swiss company, VSL. And what struck me there is the lack of knowledge, construction knowledge that was considered during design, leading to a redesign effort so the bridge could actually be built. And while that was an interesting experience for me, it really delayed the project. So this mapped well with the large focus of AI at the time, which focused on creating expert systems, applying existing knowledge broadly and consistently across discipline and phase boundaries. So one of my first projects at Stanford was to build a bridge design advisor so that designers could understand construction knowledge. That, as we all know, proved to be all a little bit too brittle. So this got us into model-based reasoning, where we started to build some data structures that could then be filled with project-specific information, and the feedback, the system became less brittle, and the feedback was more useful. So this quick glimpse from the beautiful graphics we had at the time in my PhD work. But so this model-based reasoning was quite helpful, but we quickly realized that it was actually the time dimension that mattered. So we had to get into, or mattered a lot, that we had to get into 4D models, because the sort of static 2D and 3D models that were used at the time, again, proved to be too brittle to be applicable for good humans. But it allowed us to started to formalize this our domain knowledge, something that Ian mentioned, and we could start to think about maybe we could look at many more criteria that we consider today incompletely or too sequentially. So eventually we could add simulation here, the work from Chuck Hahn 20 years ago, doing performance-based analysis of a building design for disability access, which now is, of course, much more common, but at the time, quite revolutionary. So the big difference, as reflecting, what was the big difference in the early days of AI, at least applied to our domain, and today? And basically the big difference is we have data. Oh, well, we're starting to get some data. At least I'll reflect on that. We still find it quite challenging to get a really good data set, but there is increasingly better data available, and that really changes a lot of things. So if we look at some more modern examples of what how we can think about these ways of adding value through AI, an example of how we can carry out consistent and processes more consistently and efficiently is, for example, this scan to BIM work from a few years ago by Ira Armeni. We know how to make a BIM from a laser scan. People are perfectly capable of doing that, doing it all the time as we speak, probably. But it takes quite a bit of time. At the time when we did the work, it took a human 3 work weeks to create a detailed BIM for a 100 square meter building area. maybe some people can be a little faster, but still, that doesn't give us access to a lot of BIM of existing buildings, for example, very rapidly. So by automating that process, we can free up humans to do something else. We can create better information for projects, for existing buildings in particular, or as construction progresses, more consistently, rapidly, that is valuable for the many other things that we want to do. So turning something that we know how to do into an automated process can really have huge benefits. Similarly, we have aspirations of better improved products, but we as humans have a difficult time getting there because there's simply too many options to consider. And that's where AI-based methods can help us. For example, illustrated in this system we built together with the largest wind farm builder in the US, Mortensen, worked by Forrest Flager in my research group a few years ago, where we wanted to optimize wind farms for production output and construction costs. Those have been separated because the wind farm developer had the wind data and the contractor had the construction data, and they didn't really share that with each other. But they wondered, well, could we build a wind farm that is equally as good at producing electricity with less investment costs, because we are smarter about placing the towers, because sometimes a tower will be placed in some quite difficult to reach areas that increase the construction cost quite significantly, when relatively nearby a slightly less advantageous tower position, but much, much cheaper to build, might have been available. So we did a retrospective study looking at a wind farm, a large wind farm in northern Texas. And you see here the distribution system they need to be built. The dots show the wind towers where they were placed. The gray area show the land area that could be used. And I mean, we're talking here many, many kilometers long and wide. And when we then brought these data sets together, applied optimization methods, AI-based search methods, and so on, we could then show the project team, if they had worked together from the beginning using these tools, explored the many options that are feasible, they could have built a wind farm that used less area for less money with the same electricity output. Specifically, we could show them that they could have saved 8% of invested capital and needed 10% less land. This was very attractive, of course, to them, and they, as far as I know, started to work together and share data and pursue project opportunities together. So this is something that would be really difficult for humans, if not impossible for humans to do, to think through in a time frame that you have when you design a project, to go through the many, many options, the what-if scenarios, and figure out the drivers, for example, through the parallel coordinate plots like Ian showed, that the drivers of performance. So AI tools are extremely helpful for us to add more value by creating better products. And I want to share a couple examples of new and improved processes, because I think here we see really a lot of potential. For example, the work of René Morkos, that's now commercialized in the automated scheduling tool, Alice, where we were able to work with a project engineer, project manager on a very large parking garage. And basically, over a course of a 3-day workshop, collect his domain knowledge, combine it with the scheduling algorithms that we had developed in the research group. And over the course of 3 days, instead of creating one schedule that is typically done in 3 days, look at the 4 construction strategies that this project manager wanted to explore and understand. So getting a much better decision basis for his project. So basically, this method forces you to be very clear on what are the methods, algorithms that you apply generally to scheduling, and what is the project-specific knowledge that matters and how to formulate that, so that the AI tool creates schedules that are actually believable. This is what I wanted to find out. does this project manager, very experienced project manager, believe the output of this automated tool as much as if he had made the schedule? And after a day of working with the system, he did. And then he found it extremely powerful to work through different scenarios and understand the implications on crane needs, crew needs over time, and the particular management challenges that each of those scenarios or strategies would involve. Then later on this project, as it was under construction, so again, this basically impossible for humans to do. In all the years we've done scheduling research, we have actually not found a single schedule that didn't have errors. Some basic errors. Never mind was good necessarily from a perspective of multiple concerns like short duration, consistent crews, use, etc. In other words, that couldn't be improved quite significantly. So I think this is something that humans by ourselves, we have a difficult time doing, and the tools are extremely helpful for us to create better resource allocations on our projects. Then we were excited more recently that we could actually learn about each step of the construction process by leveraging data from a crane hook from a startup called Roosevelt that gives us now detailed data on every cycle time of the installation of this project, which gives us a huge amount of data that again would be basically impossible for humans to filter through and make sense of. For a few components you could, like here, we were stunned by the level of variability that exists in installation, something the Lean community always alerts us to, pay attention to the variability. And here we're finally getting some actual data where we saw that the shear wall installation on the ground floor varied by a factor of 5. The fastest was 23.5 minutes and the slowest 111 minutes. Same shear wall, same project, same day. The difference was really the quality of the preceding work. But then we got this data as the building went up for every component, for every condition of work. And this became extremely helpful for us to understand what drives the average performance and what drives the variability that we see in the work. We then wondered, could we manage, again, this was then after the fact, could we have managed the project better? Could we have predicted better how long the work next week will take if we had used this detailed data? And this we presented a few months ago at the ENR Future Tech Conference. If we also had access to another project, same data, and we found it very helpful to not only show heat maps of where the variability is the highest on the project, but to then simulate different scenarios in terms of the quality of your predictions you make when you use the day-to-day operation by operation data versus average data, production data that is used today. And what we found, for example, is that the contractor could have planned to install 7 more parts each day with a 90% chance of achieving that scheduled target if they had used the detailed data. Of course, we don't quite yet have this management method to use this detailed data, but that's what we see as potential on the horizon. The other thing we're seeing here finally is actually data we can use that we can trust largely. There's still some errors in there, but compared to what we have seen otherwise, it's a huge improvement in quality of the data. And we see this happening across the industry more and more. A few months ago, we were able to be part of this test of using Spot to collect data on a project. And I think it opened the eyes to everybody what you can do when you have consistently collected comprehensive data that on what's going on a project. It allowed the project team to slash the payment cycles, which was very attractive for their accounting and back office functions and also their contractors. To do production tracking, air quality monitoring, quality control, all with the same, tool collecting the data, which would have required different people walking through the site with different set of eyes, seeing some things, not seeing other things, basically not getting this comprehensive data set. So hopefully I was able to illustrate to you how a quite wide range of AI-based methods allow us to add more value through creating better products, executing processes we already know how to do more often, more consistently, more efficiently, or thinking of new and improved processes. But we have to bring all of this into an organization, and Ian really pointed out very well the challenges of doing so. We have to, in our experience, we have to see what is the organization willing to accept. What level of AI performance is actually helpful? Because we get 90% accuracy. You know, the AI people are happy, construction people are not happy. But you can still do something with that. So we have found that is quite a challenge for organizations to truly understand what the AI-based systems can help them with, and what they still have to do. We saw this quite nicely done in a project we were able to do with Louis Berger, now WSP, and Aerial Insights, where we tested whether we could prototype how a drone-based and then automated drone-based inspection system for highway, coupled with automated recognition of defects, could help this operational team. This team running this organization running this highway was very motivated to find a better way of managing this project, because, well, if there is a problem on the road, it presents life safety issue also, as Ian pointed out. There was very stringent requirements from the Department of Transportation. In particular, they assumed that it would take quite a while for a defect to be found, and then they had an extremely short window to fix it. Basically, they required that every defect that was found had to be fixed within 24 hours. This led to a huge inventory of material and signs, etc., that the operator had to have at hand, because otherwise they couldn't fix it in 24 hours, which is quite a cost, of course. So they were wondering, if a problem could be found right away, could then maybe the time to fix it, depending on the type of problem, be a little more relaxed, and could you then get from a reactive maintenance regime to a proactive predictive maintenance method, which of course has been shown by many others to be much more advantageous. The challenges were that it's of course difficult to see defects as you're driving up and down the road, which was really the primary way of inspecting, and certain things it's actually difficult to see for humans in terms of, does something still match the requirements? So we were able to show a prototype system that could automatically that would collect data comprehensively, like we saw before, see things that humans can't see, and then analyze that data automatically and highlight the defects, and be able really also to show when a defect started to happen. And so this provided a much better information basis for this operator to work with its client, the Department of Transportation. In our observation, stepping back, this worked because in the operator's organization, there was something in the system for everybody. Different things, but everybody saw the value of the system. The operator, the manager of the operator, saw the better allocation of resources, better service to the client, and the maintenance staff was happy because they had more predictable work hours and work conditions. So this was a successful adoption of an AI-based system in an organization. We have seen many unsuccessful ones where the different parties in the organization were not aligned on the value of the AI system, or the expectations of the AI system were too high. So this leads me to sort of a few concluding comments, because we found, as we work with organizations around the world, that often business leaders still struggle to articulate the added value they seek. What insight should AI give? What decisions should AI support? What questions should AI answer? If unrealistic or fuzzy expectations of AI, what AI can do. They're enamored with some kind of the methods, and the methods are important, of course, we have to understand them. but we also, first and foremost, need to know what should the system help us to do. And hopefully my examples have given you some ideas there. And the other thing we consistently find is that good quality data sets are still the exception. It's difficult to connect different data sets, but that's when you really find value, when you can connect a scheduled data set with an estimating data set, with a BIM, with a contract data set. But aligning those, connecting them is still extremely challenging, we found. We find, and Ian also pointed it out, that data sets use inconsistent labels, organizations. The automated data collection changes this a lot, as I mentioned. We find that, of course, we haven't gone back and said, this was a great design, this was a really good cost estimate, etc. We don't have those labels. And so how we will learn from those, I'm not so sure. And many data sets still don't really capture the important phenomena. Ian also alerted us to this problem. So, but things are definitely improving quite significantly, opening up a world where we can envision that with AI, we can understand the past much better, what is actually working well, what is not working so well. We can imagine the future, each dot representing a design option, so that we can shape our future by picking the best design that we want for that client, for that community, for that society. So hopefully you've enjoyed my thoughts on how we can add value to project teams through the application of AI. Thank you for inviting me to this event again.